All right, here we are in Dallas, Texas still, Arlington to be exact, also known as the eastern home of Dodger baseball, the 2020 World Series champions. See again out the window there. See the stadium kind of sort of right between the window and the blackboard right there. You can see it. That's where the Dodgers won last night. How about that? So awesome. So awesome. And that's why my voice sounds like it does. But anyway, enough of that, right? Let's get into the fun stuff. 3-5. Oh, yeah. Love 3-5. Okay. So let's do a little warm up here. Let's see what you remember about solving inequalities, absolute value inequalities. So go ahead and pause the video and try number one. Okay, hopefully you realize absolute value is isolated. So you would write this as an OR and then graph it. And hopefully you have two open circles on your preliminary graphs. And then your final graph would be moved down and it would look like that. Awesome. Okay, try number two. Okay, two, again, the absolute value is already isolated. So this would become an and. So you might write it as a sandwich here and add 8 to all three parts. And then you would get 4 is less than d, which is less than 12. And what would that look like on a graph? Yep, it would be filled in between 4 and 12, not including them. Okay, number 3, go for it. Well, that's a trick one. Well, not really a trick, but you know what I mean. Is it ever possible for an absolute value to be less than 0? No, of course not. So it would be no solution. What would your graph look like? Yeah, you leave the number line blank. And how about number 4? Yeah, greater than a negative. It's always going to be greater than a negative. All real numbers. What would the number line look like? All filled in. Lovely. We'll make sure you guys stay on top of that. So hopefully that was some good review. All right. So now let's make a table of points and plot them in a coordinate plane. I've got one big graph here for you to use. So you might want to color coordinate this. But let's do this. So let's pick some, what would make most sense? Probably pick numbers to plug in for X, right? And then it's easy to simplify the right side of the equation and figure out what Y would be. So go ahead and do that. If you want to use the same numbers I use 0, 1, and -1. So why don't you go ahead and do that? So hopefully you got -3, -5, and -1. You've got 3 ordered pairs to plot, 3 points to plot, right? 0, -3, plot that one. 1, -5, plot that one. -1, -1, plot that one. Okay, and then y equals 5x. Again, you do it the same way. And if you use the same numbers I use, 0, 2, and -2, what would you get for your y values? Hopefully you said 0 and 10 and -10. Awesome. And then number 3, as we know, if it's just y equals 0, we know what kind of line that's going to be. It means that it's going to be a line where every single point on the line has the same, my computer needs to be plugged in here, has the same y coordinate. And what would that y coordinate be? Yeah, it'd be a coordinate of 0. So it's going to be a purple line here. So hopefully you've graphed all 3 of these lines. If you haven't, do so now. Uncover here. 3, 2, 1. Boom. There you go. So there's our number 3, our purple one. Number 2 is our red one. So you can see 0, 0 right there. 2, 10. -2, 10. I think this got moved down. That's weird. It should be, move this point. This should be up here, right? Yeah. And then here's our blue one. Okay. Notice how all the points line up, all the points line up. And of course, we knew that one was going to be a horizontal line. Okay, so our learning target, our plan here is to be able to describe the graph of an equation in the form of y equals mx plus b, and also learn how to graph something that's in that form really rapidly and quickly. instead of having to do all this stuff where we have to make a t-table and ordered pairs and all that, because it can be a little tedious. Okay, so slope. We haven't really talked a whole lot about what slope is yet. Slope, which we normally use the letter M, and if you want to go and do some research on that, let me know what M stands for. Why do we use M for slope? I'll also throw out another extra credit, which I meant to mention at the beginning, which is give me some good Dodger World Series trivia. Good World Series trivia for the Dodgers, and I will be happy to give you a point of assignment extra credit. All right, so two different assignments there for you, our extra credit assignments. Okay, but anyway, slope M of a non-vertical line passing through 2 points, and we're just going to call those the coordinates of those 2 points x sub 1, y sub 1, and x sub 2, y sub 2. Don't get confused by the little ones and the twos. It's not saying it's 1 and 2. It's just saying like, oh, we'll just call point 1 coordinates x1, y1, and the coordinates of point 2, x2, y2. Okay, anyway, it's the ratio of the rise, in other words, the change in the y coordinates, to the run, which is the change in the x coordinates. So can you see that if we went from this point up to this point, our rise would be whatever the coordinate here is of y sub 2 minus the coordinate of y sub 1. And the run would be going from here to here, the coordinate of x, the x coordinate of x sub 2 minus x sub 1. Okay, so slope, which we use M usually, is the rise and the run, or the change. Sometimes you see that with a triangle like delta. Delta, change in y. Oh, what happened there? Change in y over the change, that's a triangle, believe it or not. That is not a very good looking triangle. Let me fix that. Change in y over the change in x. Okay. When a line rises from left to right, so it goes up this way, the slope is positive. When the line slopes down from left to right, it's going to be negative. And think about this. If we're going here then here, right? Or better yet, here and then over here to get from one point to another, isn't it a positive rise? We're going up, right? Positive over a run to the right, which would also be the positive direction for the x-axis, right? If we had a line where we were going down, right, then what we would have is, let's say we picked a point right here, and I'm just randomly picking points, doesn't matter. Wouldn't this be going down, which is negative, and then to the right here, which is positive? So a negative divided by a positive, right, would get us a negative slope, okay? Now you might be saying, well, yeah, but what if you go from this point down to this point? You could, but that would be negative and then over a negative, which is equal to what? A positive, right? Okay, so let's find the slope for these, okay? And we'll also find the y-intercept, okay? Remember, the y-intercept is the point or the location, the coordinates of the location where your line intersects the y-axis, okay? So, all right, so let's find the slope here. So let's just count and see. Okay, so like, let's see. Looks like it goes through right there, which is what? -3, 0, and then it goes through right here, which is at 0, 2. So if to go from this point, let me even draw this on here. So to go from this point to this point, I would go up 2 and to the right 3. Well, that would be what? What's the slope? Rise of a run, rise of 2, run of +3, slope is 2 over 3, 2/3. Okay, and what's the y-intercept? Oh, well, we just said that. It's right there, 0, 2. Okay, so it's what? 2. Now you might be saying, yeah, well, okay, Mr. Campbell, you just chose these 2 points just to make it work. Well, what if I chose this point instead? So let's say I chose that one, and let me get rid of this point, and I chose that point down there, okay? What would my rise be? 1, 2, 3, 4. What's my run? 1, 2, 3, 4, 5, 6. What is 4 over 6 reduced to? 2/3, yeah. By the way, notice how they've given us the equation for this line in y equals mx plus b form. Notice the coefficient in front of the x. It's a 2/3. Wow, incredible how what we did by looking at the line also matches the equation. And notice the +2 is our y-intercept. Huh, I wonder if that will always be the case. Well, let's look at B and C. Okay, so let's find the slope. So let's go from right here to way down here. Okay, so let's see. 1, 2, 3, 4, 5, 6. So -6, because I'm going down 6, and then to the right, which is positive. 1, 2, 3. What's -6 over 3 reduced to? -2. Oh my gosh, it matches that. How about that? And then here's our y-intercept, right? And what's the coordinates of that point? 0, -1. Oh my goodness. So our slope is -2. Our y-intercept is -1. Crazy how that matches. Awesome. Okay. So describe the slope. Is it positive or negative? And they've already done the kind of the rise here and the run for you. 4 over 6. What do you think? Positive or negative? Positive, yes. And the slope 4 over 6 reduces to 2/3. We always reduce if we can. We always reduce. Okay. How about this one? Hopefully you said negative, right? Because we're falling 3 and then going to the right 2, or going to the right 2 and going down 3, right? So it's slope of what? -3/2. One thing I'm not crazy about is the fact how they do the run first, because it's rise over run. Usually people like to go down and to the right. But just remember, the vertical change, the change in the y's, is on top of the change in the x's. And again, notice here, let's go back to this one over here. Notice the change in the y's would be what? Change, difference. 2 minus -2 is like 2 plus 2, which is 4. 3 minus -3 is like 3 plus 3, which is 6. 4 over 6, again, reduces to 2/3. Okay. All right, why don't you go ahead and try these. Okay, hopefully you got that this is negative. It's sloping down, right? And what did you get for the slope here? Hopefully -2/5. Down 2 to the right 5. Down 2, negative, +5 going to the right. Or could go up 2 and then to the left -5, right? That would be a +2 over a -5. Same thing, I get -2/5. All right, do the next one. What's the description? Positive or negative? Positive, it's going up to the right, and then figure out the slope. Hopefully you got 4 over 6, okay, right? Up 4 over 6, okay? Or down 4 to the left 6, okay? That would be a negative movement and then a negative movement. Negative divided by negative gets us back to a positive. Change from the y's, 3 minus -3. We just did this. 6 over, I'm sorry, 3 minus -1 would be 4. And then 3 minus -3 is 6. 4 over 6 reduces again to 2/3. How about this one? Hopefully you're noticing positive, sloping up to the right. What's our slope? Rise of what? Notice each one here, the spaces are 2, by the way. Be careful about that because they do that once in a while. Always got to know what your spaces represent. So this would be what? Up 1, 2, 3, 4, 5, 6, 7. So rise of 7, run of 1, 2, 3, 7/3. Okay. All right, cool. All right. So here, the points represented by each table lie on a line. So they're telling us they're on a line. How can you find the slope of each line from the table? Well, what have we seen about the change in x's and change in y's? Haven't we always seen that it's got to be constant for it to be a line? If it's not, then it doesn't line up, right? It's a curve or something like that. So, let's see if we can figure this out. What's the change in the x's from one point to another? +3, +3, +3. What's it, the change in the y's? -6, -6, -6. So between any 2 points, isn't our vertical change -6, our X change, our horizontal change is +3. Well, -6/3 is equal to -2, okay? And you can really pick any two ordered pairs. So let's pick this one, the top one and the bottom one. I could go 20 minus 2, which is 18, over 4 minus 13, which is -9. What does 18 over -9 reduce to? -2, okay? All right, so try it with this one. This one's a little interesting, isn't it? Notice, is there any change in the y's? No. What kind of line would not have any change in the y coordinates of the points? Every point that's listed there, -1, 2, 1, 2, 3, 2, and 5, 2, all have the same y coordinate. What kind of line? Visualize it. Graph it if you need to. What kind of line is it? It's horizontal, right? So we would get a slope of 0. Any horizontal line always has a slope of 0. There's no rise, right? There's plenty of run between 2 points, right? If I had a line and if I had a line, right, that's horizontal, and I had a point right here on it, and I had a point right here on it, there's no rise, there's no change in y, but there's plenty of change in x between the 2 points, okay? All right, cool. Next one. What do you notice about this one? Oh, all 4 ordered pairs have the same x value. So what would that look like? What kind of line would that be? Hopefully you're seeing that it's a vertical line, right? The points would kind of line up, boom, 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 right? And what kind of line is a vertical line? Does it have a slope? No, it does not have a slope, right? So think about it this way. What would be the change in the y's going from -3 to 0? It would be +3, right? The run would be 0, right? -3 minus -3 is like -3 plus 3, which is 0. Can you divide by 0? No, it's undefined. So we call that undefined slope or no slope. Either one is fine to say. Okay. Okay. What's the slope of each of these lines? Go ahead, work on it. You can use any of those methods we just talked about. Okay, hopefully for this one, you did change in y's. I just picked the first 2 points. So 15, 4 and 10, 2. So 15 minus 10 would be y2 minus y1. 4 minus 2 would be x2 minus x1. And I reduce that, or I simplify that, and I get 5/2. Again, doesn't matter which way you go with whichever 2 points. Let's pick this point and this point. What if I went 10 minus 25 over 2 minus 8? 10 minus 25 would be -15. 2 minus 8 would be -6. What is -15 over -6 reduced to? 5/2, positive 5/2. Okay, try this one. Okay, hopefully on this one, you ended up getting 3/0, which is no slope or undefined slope, right? Think about how these points would show up. They'd be basically 1 here, 1 here, 1 here, 1 here at, where x is equal to 5, okay? All right, so here's a summary of this, right? Line that goes up from left to right, gonna have a positive slope. Line that goes down from left to right is a negative slope. Horizontal line, 0 slope. Again, why? Is there any rise between picking any 2 points on this? No. Is there run? Yes. What's 0 divided by a number? 0. Okay. So you can read that because there's no rise, but run between any 2 points on the line, and 0 divided by any number besides 0 is 0. And then the fourth possibility is we just talked about is a vertical line. And what do we say? We say that's undefined slope or no slope, because you've got plenty of change vertically between any 2 points, but no run. So it would be a number over 0, and you cannot divide by 0. All right, so let's work on this. Again, this is like kind of normally this would be like the second half of the lesson, but you can pause, take a break. This would be a good time to do that. If you want, take a stretch and then come on back. Okay, so work with a partner, graph each equation using the online Desmos graphing calculator, then complete the table. okay? Use the completed table to write a conjecture about the relationship between the graph of y equals mx plus b and the values of m and b. Okay, so let's go to Desmos. I'm going to show you how to do that. You should know how to do that already. Oh, we don't want to go there though, do we? Do I have it open? I don't have it open. Let's do that. Buy my Dodger gear. How about that? That was pretty cool, huh? All right. So let's go to Big Ideas and enter my password. Isn't this fun to watch? Okay, so remember how you get there. You're going to go to the three little hamburgers up at the top. You're going to click on that. You're going to go to Math Tools and look for Desmos Graphing Calculator. And you would then type in one of the equations. So let's go back to the notes. Let's pull the first one. I'll just do the first one. Y equals negative 2/3 x plus 3. So we would go, back to here. And we would go y equals negative 2/3 x, I think it was plus 3, I believe, plus 3. And there's our line. What do you notice? What is the y-intercept? It's right up here. Oh, yeah, see when I put my there? 0,3. Okay, so our y-intercept is 3. What's our slope? Okay, careful now. If we go, let's go with this point, and let's go with this point right here. Okay, so I'd go down. That's going down 1, isn't it? Because each of these boxes, here, let me fix that. Let's zoom out. Now each box is worth 1. So let's go with this point and this point right here. I'd be going down 2 and over 3. So negative 2/3. Negative 2/3 is our slope. So that's how you can use Desmos, okay? You could actually do another one right on there. I'm not going to go through the other ones. So let's go back to the chart. And so what was our description? It was a line. What was our slope? We said it was negative 2/3 and 3. Notice how those match. So go ahead and try the others. Use Desmos, get some good practice with it. It's kind of fun anyway. Okay, so hopefully you got that it was a line, that the slope was 2, and the y-intercept was negative 2. On this one, it turned out to be a line. Notice these are all in y equals mx plus b form. Slope was negative 1, y-intercept was positive 1. Another line, slope was 1, y-intercept was at 0, negative 4, so it's negative 4. So the value of m affects what? What does that do to our line? It affects the steepness of the graph and where the graph rises and whether the graph rises or falls to the right, right? It rises to the right if it's a positive slope. It falls to the right if it's a negative slope. And what is the value of b impact? It's the y-intercept, right? So it says where the line crosses the y-axis. It's the location of the y-intercept. Okay, so again, y equals mx plus b. We call that slope-intercept form. Learn it, love it, know it. Slope-intercept form, y equals mx plus b. M is the slope. Again, you're at that extra credit. Tell me why it's m. I'll give you a point of extra credit. Make sure you cite a source. And b is the y-intercept, okay? All right, so here's y equals 3x minus 4. What's the slope? You should be able to look at this and just pull it out. M is 3 here. Y-intercept is b, and that's what? It's negative 4. And y equals 6.5. So how could I write that in slope-intercept form? Y equals 0x minus plus 6.5, excuse me. So what's the slope? 0. What's the y-intercept? 6.5. All right. So what kind of line is this? Yep, it's horizontal, right? No slope, or not no slope, 0 slope. No rise, plenty of run between points. Okay, what about this one? Is this in y-intercept form? Is it in, I say y-intercept, it's slope-intercept form, but sometimes people call it y-intercept form. That's how actually I was taught way back in the early 80s, call it y-intercept form, but we call it slope-intercept form more now. No, it's not. So put it in that form. What would you do? Add 5x, and then we don't want negative y, we want positive y, so we would divide everything by -1, and we end up getting y equals -5x plus 2. So what's your slope? Good. And your y-intercept is 2. All right, so go ahead and do these. Okay, should have got -6 and 1. Could write it like that if we wanted to, or just realize this means every point on the line has the same y coordinate, which means it has to be a horizontal line. So it means the slope is 0 and the y-intercept is 8. Okay, last one. Again, got to put it into slope-intercept form. You don't have to actually, but you can. And then here's your slope. And whoop, sorry about that. There's your slope and your y-intercept. Hopefully you got -5/2. Okay. Don't have to change that to -2.5. You can if you want, whatever works for you. Okay, so it says graph 2x plus y equals 2 using slope-intercept form. Is it in slope-intercept form? No. So put it in slope-intercept form. Okay, so there it is. So what are we going to do? What's the first place you're going to go to be able to graph this? Because remember, you need how many points in order to draw a line? You need 2, right? So where could you go? Do you have a point? Do you have a point here? Of course you do. This is the y-intercept, so we know I can go to 0, 2, right? So I'm going to go to 0, 2, and then once I've done that, I have a slope of -2. And remember, this -2 is like -2 over 1, right? So what's the vertical change? -2. So down 2, and then the horizontal change would be +1. I can then plot a point there. That's 1, 0, and I can draw my line, okay? Then we're supposed to identify the x-intercept. Remember, the x-intercept is where your line crosses the x-axis, and obviously that is at 1, 0. So the x-intercept we say is 1. Now you might be saying, how do I know I drew the correct line? Well, you could always pick another point on your line, because remember, every single point that's on this line is a solution to the equation of the line that we just of the graph, right? The line makes up all the infinite possibilities that would make this true. So let's go and pick another point. Let's pick this point right here. What is that? That is 1, 2, 3, comma, what? 1, 2, 3, is that 4? 1, 2, 3, 4. Yeah, 3. So it's 3, comma, -4. Okay. Now watch this. If I plug in 2 times 3 is what? 6 plus y, which is -4. So I have 6 plus a -4. 6 minus 4 equals 2. Oh my goodness, our magic number of 2 on the other side. Check, check. Okay. Graph the linear equation, identify the x-intercept. So similar time problem. So go through it and try and do exactly what we did at the other side, on the other one. Go for it. Pause it and do it. You got this. Just like Mookie Betts did last night. Oh, yeah. All right. So hopefully the first point you plotted was 0, -4. And then you realized your slope was 4 over 1. So from 0, -4, you could go up 4 and to the right 1. And then you plot that point, you'd have 1, 0, which just happens to be your x-intercept. How about that? Oh my goodness. Thank you, ladies and gentlemen. Or couldn't we have gone down 4, 1, 2, 3, 4, and over to the right one and plotted a point right here, right? And then we could have drawn the line. Notice a point right here lines up perfectly well with that, right? It would have, if I continue this line down, it would have hit that. Awesome. Okay, so a linear function g models, so linear, remember it's gonna be a line, models a relationship in which the dependent variable increases 3 units for every 1 unit the independent variable increases, okay? So remember what, and I've got it here for you. Remember, the independent variable is always x, Your dependent variable is y in a function. Okay, so it says graph g when g of 0 equals 3. Identify the slope, the y-intercept, and x-intercept of the graph. Okay, so there's a lot there. Let's break it down. So again, x is the independent variable, y is the dependent variable. So what does g of 0 mean? That means that when the dependent variable is 3, when the independent variable is 0. Well, doesn't that give us a point, right? We know that when x is 0, y is going to be 3, right? In other words, we're throwing 0 into whatever the equation is for this linear function, and 3 is getting spit out. So we can go and put in 0, 3, okay? All right. So we also know, so I've plotted this point. Forget about the other stuff right now. I've plotted 0, 3, right? We also know that the dependent variable increases 3 for every 1 unit. The independent variable increases 1, right? So what does that mean? It means y is going to increase by 3, 1, 2, 3. For every unit, the x variable increases by 1, 1. Oh, so the slope is 3 over 1, or we would just call that 3. So we would go up 3 and over 1. So what's our y-intercept? Oh, well, we already did that, right? 0, 3 means 3 is the y-intercept. And what's the x-intercept here? If I went down 3 and over 1, it's at -1. Awesome. Okay. So here's another one. Try this one. Similar problem, just different numbers. So the linear function h models a relationship in which the dependent variable decreases 2 for every 5 units, independent variable increases. Graph h when h of 0 equals 4. So did they give us a point? Yes, indeed, right? They're telling us that when x is 0, y is 4. Okay, so we can go and plot 0, 4. Okay, so we also know that our y-intercept is 4, right? So they've given us that. And we know that the y, the dependent variable, decreases, goes down by 2 for every 5 units independent variable increases. Well, so what does that mean? It means our y is -2. Our change in y would be -2. Our change in x would be 5. So our slope would be -2 over 5. So from this point that I know is on my line, I could go down 2 to the right 5, right? Negative, positive, it's -2/5. And then plot this point, it's 5, 2, and boom, there I have it. My slope, -2/5. I still need to figure out that x-intercept. So if we just continue the line, we would see that it crosses at 10, 0. So the x-intercept would be 10. How did I get to that point? I went down another 2 over 5, and there we have it. All right. Okay, so we have a submersible. It's like a submarine that is exploring the ocean floor and begins to ascend to the surface. It means ascend means to go up to the surface. The elevation h and phi of the submersible is modeled by the function h of t equals 650t minus 13,000. Hope they tell us what those variables represent. Oh, h is elevation. Okay, where t is the time in minutes since the submersible began to ascend. So let's think about what's going on here. We have a submarine, right? It's way down in the ocean floor. How far down is it? Can you tell? Hopefully you're saying 13,000 feet, right? Starting 13,000 feet below, so that's why it's negative, below sea level, right? And how fast is it going up? That's the 650, right? Notice that's a positive slope. This is in slope intercept form. Did you notice that? H of t or y equals 650t minus 13,000. That's y equals mx plus b, isn't it? Okay, so let's graph the function and identify its domain in range. So do we have a point there that we can plot? Yeah, we have the y-intercept, right? So we know what are the coordinates of the y-intercept? It's going to be 0, negative 13,000. So let's go and plot that. So notice what I've done. I've set my elevation to be kind of my y-axis and my horizontal to be my time, right? Makes sense for elevation to be up and down, doesn't it? Okay, notice I'm only down here, if I had drawn an entire Cartesian coordinate system, I'm only down here in the fourth quadrant because this is a real life situation. It's not like the submersible is gonna all of a sudden shoot out of the water and like start flying like an airplane, although that would be pretty cool. Okay, so where's the first point I can plot? It's right here, okay? It's 0, negative 12,000. Now, what's my slope? 650 t. So what I could do, since I know my slope is 650, again, means it's going up 650 per minute, I could go and plot another point after a certain amount of time has passed, right? So, oops, what happened there? There we go. So you could plot any point along here. So like, for example, we could plug in, I don't know, plug in 20, right? If we plugged in 20 times 650 just so happens to be 13,000. Minus 13,000 would get us a y of 0. We could have picked this point here and plugged in 4 for t. And if we plugged in 4 for t, that would have been 2,600 minus 13,000 would have been, what is that, negative 10,400. So we would have gone to 4, negative 10,400, plotted a point there. And then we could have connected the two dots and extended the line up, okay? So again, the y-intercept is 13,000, okay, below sea level at 0 minutes, hasn't started to rise, then it rises. What does the graph tell us? How long does it take for it to get to the ocean surface? Ocean surface has a elevation of how much? 0, right, sea level? Okay, so our x-intercept is right here. So it reaches it at 20 minutes, okay? And I believe that is the end. Oh, no, we got one more. Okay. What about this one? Same thing, except what's two things that are different? Yep. It's going up at 500 feet per second instead of per minute instead of 650. And it started a little higher. It's only 10,000 to start with. So go ahead and try doing this one and I'll just uncover. Okay. So hopefully you had this here. And we wanted to identify the range and the domain. The domain would be like our time, right? And it's from 0 out to, looks like 20 again, right? So t is sandwiched between 0 and 20 inclusive. And our range, what's the lowest it ever is? 10,000 or negative 10,000 feet below sea level. And it goes up to sea level. So h is sandwiched between negative 10,000 and 0. Okay, so what does the slope mean? What's that 500 again mean? Yep, that it's going up at 500 feet per minute. And what is the h-intercept or the y-intercept saying? That it started at 10,000 feet below sea level, okay? What does the t-intercept or x-intercept represent? It's basically saying it gets to the ocean's surface at sea level 0, right? After 20 minutes. All right, well, that does it. If you have questions, we can definitely go over that in class or come see me at contact time. Go Dodgers, world champions. Very happy about that. Hope you are too. Have fun with it. And I will see you guys soon.